So the last topic we're going to look at is matrix solutions to linear systems, and that's quite a title there. So really, this topic we could spend easily a full unit on it. Also, there's class design for linear systems called linear algebra, so you could spend a whole semester on this kind of stuff. So this is just going to be a brief overview of matrices to find solutions to linear systems. So first of all, what's a linear equation? A linear equation is going to be a set of two or more linear equations containing two or more variables. So typically something like, 3x plus 2y equals 8. And then the other one would look very similar, maybe something like, negative 5x plus y equals negative 7, something like that. I just made that up. But that would be a system. It's two linear equations with two variables right there, x and y. So the solution to these systems of equations is going to be where the lines intersect. So you have to find an ordered pair that satisfies both equations. So for example, right here, there's one solution. It's where the two lines intersect. So if you were to graph them, the intersection. Now, sometimes these lines end up being parallel and they don't intersect. So there's no solution. Then sometimes the lines are actually on top of each other. Okay, so there's really two lines there. So they share an infinite number of solutions because they share an infinite amount of points. The ones we're going to focus on are one solutions. Okay, are only having one solution. Okay, these other ones are very important, but it's just not something we're really going to look at in this little brief introduction. Okay, so in some of the stuff it's assumed that you're somewhat familiar with. Okay, so we're going to look at augmented matrices. So really the beginning of this is just going to be vocabulary. Um, so a matrix gives us a shortened way of writing a system of equations. The first step in solving a system of linear equations using matrices is to write an augmented matrix. An augmented matrix has a vertical bar separating the columns of the matrix into two groups. The coefficients of each variables are placed in the left of the vertical line, and the constants are placed to the right. If any variable is missing, we're going to put a zero in there. So here's some examples. So these systems of equations actually have three variables, okay? And so they have x, y, and z. And so the way an augmented matrix works is you're just putting the coefficients there, and we're basically just dropping the variables out of there. So you can see 3, 1, 2, 31, and so on. Okay, so this is kind of similar if you remember back with synthetic division, when we would use the coefficients for synthetic division. It's kind of the same idea. We're kind of just trying to make the process easier on us. So it's not that they are like just go away. We're just kind of setting them off to the side for a moment to help us with the arithmetic so they basically don't get in the way. On our second example, same thing here. So 1, 2, negative 5, negative 19. Now, if you notice, I didn't have an x, so I had to put a 0 there. And then on the third one, I didn't have an x or a y, so those had zeros also. So on this first part, pretty basic. It's just making sure we can rewrite this as an augmented matrix, because if we can't do that, then we can't actually solve these. So right now, we're not even solving. Right now, we're just trying to make sure we can set them up properly. So on this first one right here, let's see, we're going to have a 2, a 3, a 1 in the x column. Then let's see, we're going to have a 1, negative 5, negative 2, then a 2, negative 1, negative 3, and then we draw that bar, and then we'll have 2, 4, negative 6. Okay, on our second example here, let's see, for the x's, so be careful. So I do have a 5, a 1, and a 2. So see those x's, even though they look like they're in the wrong column, it's just the way it's typed out, okay? So just kind of be careful about that. Our second column, our y column, let's see, we're going to have negative 2, then we will have 1, and then the third one doesn't have a y variable, so we have a 0 as a coefficient. Then our last our Z column, we're going to have -3, 0, and -3 again. Draw our bar, 0, 5, 4. And there's our augmented matrix. Okay, so I'm not going to read all this, so I'm just going to kind of discuss what it says, and you can read this on your own if you'd like. But basically, what we want to do is we need to get diagonal ones going across. And so now we're going to start looking at how are we actually going to solve these? How are we actually going to find our solution, the common point that all three equations intersect, okay? And so what we have to do here is we have to get this diagonal of ones. And so we have to figure out a process for getting zeros in these other spots. And so that's what we're going to do here. Okay, so this just talks about the row echelon form. That's basically the diagonal ones right there. Okay, so what we're going to do is we're going to practice doing row operations. Okay, and so these are the different row operations you can do. You can interchange your rows. Okay, so if I want to move a row, I can move them. So let's go ahead and do that. I'll go ahead and do this because this is telling me, basically it says take row 1 and switch it with row 2. Okay, so what that means is that row 2 is going to move up to row 1. So I'm going to have 1, 5, -5, 0. And then row 1 moves down to 2, -6, 4, 10. And then row 3, nothing changed there. So I just go ahead and keep that there. So that's one of your row operations. Another operation you can do is you can multiply a row by a non-zero constant. So you can take a row, whatever row you want, and you can multiply by 2, 3, 1/3, whatever you want to multiply it by, and that would be your new row. So notice that this has just one arrow pointing right here. There's no swap. We're just changing some row into this new row right here. So looking at example 14, so what's going on here is we're taking, this is going to stay in row 1 right here. So we're going to take row 1 and you're going to multiply all the terms by 1/3. So let's see, 1/3 of 3 would be 1. 1/3 of -12 is -4. A third of 6 is 2. And a third of 9 is 3. Now, nothing else changes. So everything else we are going to leave the same. Okay. And then the last one that we can do, which is kind of interesting, is you could multiply a constant by some row, any row you want. It doesn't have to be a particular one, and then you can add it to a different row and then replace that row that you're adding it to. Replacing it replacing that row that had that constant that was multiplied by the original row can be added to the new row, and that's what's going to replace it. So that one's a little complicated. So let's go ahead and do it, and then you'll see it's not as bad as it sounds. So let's see. Oops, this just keeps jumping on me. All right, give myself plenty of room. Okay, so what's going to happen here is we're replacing R2. What we're going to do to row 2 right here is we're going to multiply row 1 by -3, and then we're going to add that to the row 2 right here, and that's going to be my new row. So what doesn't change is row 1 and row 3. Those are going to stay the same. So I'm going to go ahead and fill those out because those do not change. Okay. So what's happening here is row 2 is what's going to be adjusted. Multiplying -3 by row 1 and then add that result to row 2. That's my new row 2. So let's see. This would become -3 if I multiply row 1 by -3. That becomes -3. -3 plus 3 is 0. This would become +9. 9 plus 1 is 10. This would become -6. -6 plus -1 is -7. And then let's see, -3 times 0, that would be 0. 0 added to 7, that would just stay as 7 right there. Okay, so that's the most challenging row operation we have. It's not that bad. You just might need to practice it a couple of times to kind of make sure you got it. But what I did was I multiplied the first row by -3, took that result, added it to row 2, and then that was my new row that I have right here for row 2. And like I said, this is kind of similar to synthetic division. Uh, if I were to put all the variables back, it might kind of make a little bit more sense of why I'm allowed to do these row operations, but you kind of want to get rid of the variables while you're doing this process because it just makes it easier to work with. Okay. All right. Okay, so here, this is going to basically tell you the process on how to get it in reduced row echelon form. So the idea here is that what we're eventually going to want, let me get a new page and show this to you. So you're going to start out with, something kind of complex. And the idea is you want to get these down to ones, and you'll have zeros here. And then if you have that there, if you were to put the variables back, basically you would know that right here, 1z is equal to, and then, whatever value is right there. So you'll know what z is. And then once you know what z is, you can plug it into right here and you can solve for what y is. And then once you know what y is, then you can plug in y and z here and you can figure out what your x is. So that's kind of what's taking place here is putting it in reduced echelon form is going to allow us to solve for z. Then once you know z, then you can solve for y, and it's called back substitution. And so that is what we're going to do here. So this kind of just tells us the order that we want to do this. You want to start, you need a 1 in your top left-hand corner. Then you need to somehow turn these into zeros right here, and I'll go over that in a moment. Then you want to turn this into a 1, then turn that into a 0, then turn this last one, your last diagonal, into a 1, and then you're ready to do your back substitution. All right, so I have two examples for us. And from my experience, students actually kind of enjoy this. They kind of find it somewhat fun. So what I'm going to do here, first I'm going to put this as my augmented matrix. So I'm going to get rid of the variables. So we're going to have 3, 1, 2, 31. See 1, 1, 2, 19. See 1, 3, 2, 25. Okay, so the first step is to get a 1 right here. I need a 1 right there. So what I can do, and it doesn't really matter which one I do, I need to swap it with either row 2 or row 3 so that I can have a 1 up there. And so it doesn't really matter which one I do. One might make my life easier in the long run, but I can't really tell. So I'm going to go ahead and just swap row 1 and row 2. And so let's see. So now I'm going to have 1, 1, 2, 19 on top. And then the 3, 1, 2, 31 go in the middle. And then still have 1, 3, 2, 25 in the bottom. Okay. So now what I have to do is I have to turn these into zeros. I got to turn those into zeros. So what I'm going to do here, I'm gonna run out of room. I might be able to fit it right here. Eh, probably not actually. So I'm gonna work vertically. Okay, so what I'm gonna do here is I'm gonna multiply -3 by row 1. I'm gonna add that to row 2. Okay, and then that will be my new row 2. That will be my new row 2. And to save time and space, I'm going to go ahead and do my row 3 also. I'm going to multiply row 1 by -1. I'm going to add that to row 3, and that will be my new, row 3. That'll be my new row 3. So I'm going to do both of those at the same time right here. So nothing is going to change to row 1. It's still 1, 1, 2, 19. Now what I am going to do is I'm going to multiply my row 1 by -3 and add it to row 2, and that will be my new row 2. So -3 times 1 is -3. Added to 3, that turns into a 0. So I wanted to do that. I'm going to color code this. So I wanted to do that because I needed that to be a 0. Then -3 times 1 is -3. When I add -3 and 1 together, that's a -2. Then -3 times 2 is -6. -6 plus 2 is -4. And then let's see, negative 3 times 19 is negative 57. And so then let's see, 57, negative 57, if I add 31 to it, let's see, we'll take the difference, should be negative 26. Okay. Um, let's see, now for my third row right here, we're going to multiply the top row by negative 1 and then add it to my bottom row. So let's see, that would become 0. That would become 2. Let's see, that would become 0. That's interesting. That might be beneficial. And then let's see, that will become positive 6. Okay. So I got the zeros here. Now I need a 1. I need to get a 1 here. So the thing is, I have a 0 right there. Actually, that probably won't be an issue. Okay, that should be fine. So what we'll do here, my next operation, I need to turn this into a 1. What I'm going to do is I'm going to take, I'm going to multiply negative 1/2 by row 2, and that'll be my new row 2. So I'm going to take all these and divide them by negative 2, basically, and that will turn that into a positive 1 right there. So let's see. My top row stays the same. Oops. So 1, 1, 2. 19. So 0 times negative 1/2, that's, keep that 0. That would turn into a positive 1. That would turn into a positive 2. That would turn into a positive 13. And then on bottom, I've got 0, 2, 0, 6. Okay. All right. So then the next step would be to turn the 2 into a 0, and that's what we'll do in just a minute. And like I said, all this is up here, so if you follow these steps up here, I'm just following this right here. Okay, so you can always refer back to that. Okay, and I'm going to give myself some more space. Okay, so to turn that into a 0, what I'm going to have to do is I'm going to have to multiply the row 2 by negative 2. I'm going to have to add it to row 3, and that will be my new row 3. So my first row stays the same. Second row stays the same. And then, so I'm going to multiply these by negative 2 and add it to my third row. So that keeps that at 0. That will turn that to a 0. That will turn this to a negative 4. And then let's see, I multiply that by negative 2. Let's see, that would be negative 26. Added to 20 is negative 20. There we go. Okay. And so what we'll want to do next is turn that to a 1, and then we'll be ready for back substitution. I know this is somewhat of a long process, but like I said, from my experience, a lot of times students uh, kind of like it. I don't know. So we got to turn this into a 1. So what we're going to do is we're going to multiply that by the reciprocal, which would be negative 1/4. So we're going to multiply row 3 by negative 1/4, and that will give me my new row 3. So my first 2 rows stay the same. Okay, so when I multiply by negative 1/4, those zeros stay as is. That would turn that to a positive 1. That would turn that to a positive 5. Okay. Okay, it feels like we should be done, but actually now we're actually ready to get our solutions. Okay, so give myself plenty of room for this. This won't be that bad. So what you can do is you can actually, to make sure this makes sense to y'all, what I'm gonna do is I'm gonna put the variables back. So this would be x plus y plus 2 z equals 19. Then y plus 2x equals 13. Oh, I'm sorry. It should be 2z right there. 2z equals 13. And then z equals 5. So we we know what z is. Z is 5, so that part's done. So now we're going to plug it into this equation right here. So y plus 2 times 5 equals 13. So y plus 10 equals 13. We'll subtract 10 from both sides, and we figure out that y equals 3. Yeah, 3. So y equals 3. So now we know z and we know y. The only one we don't know is x. And so we'll take this right here. So we don't know x, but we know that y is 3, so I plug it in. We know that z is 5, so we plug that in. And then that equation equals 19. And we'll do the algebra here. So x plus 3 plus 10 equals 19. X plus 13 equals 19. And then we're going to subtract 13 from both sides. And we're going to get x equals 6. So there are 3 answers. Now, the way you put your answer in is we put it in as an ordered solution. So basically, once again, if you were to take an in-depth course on this, you would learn about the z-axis. But basically, you want to put your answer in the form of x, y, z, like kind of like how we do our ordered pairs, okay? But except being a pair, there's 3 of them, okay? So my answer would be 6, comma, so the y value is 3, and then the z value is a 5. And so that's my actual answer right there. That's how we'll put in our answer solution. And like I said, if you were to take a course on this, you would learn that you can create an axis like this where you have your x, your y, and your z-axis. Basically, you're looking at lines still, but you're just looking at them in a three-dimensional plane instead. So anyways, if you're interested in the course later on this. Okay. All right. So I've got one more example we'll look at, and then hopefully, you got something out of this. Like I said, it's just a brief introduction to this topic. Um, okay, so looking at this one here, we're going to start by putting it in the augmented matrix. So let's see, we have 0 here. Let's see, we have 3, -1, -1. Then we have 1, 5, -1, -4, -3, 6, 2, and 11. So remember, I need a 1 up here to start with. So what I'm going to do is I'm going to swap row 1 and row 2. That'll do that for me. So now we have 1, 5, -1, -4. And in the middle, 0, 3, -1, -1. And then the bottom, -3, 6, 2, and 11. Okay, so we got our 1 there. Next is we need zeros here. Well, that's fortunate. I already have 1, 0 already there, so I only have to worry about row 3. So let's see, we're going to multiply the top row by 3 and add it to the bottom row. So row 1, I'm going to multiply by 3. I'm going to add it to row 3, and that will be my new row 3. So row 1 and 2 are going to stay as is, so no adjustment to those yet. Okay, so here we go. 3 times that, 3 plus -3. I'll color code this. That will turn to a 0. That'll be 15 added to 6. Let's see, that would be 21. 3, let's see, that'll become -3 plus 2 is -1. Let's see, that become -12. -12 plus 1 is, let's see, -1. Okay, looks good so far. All right. Ooh, this looks like this might get a little messy. Um, it's not that big of a deal. I know all these answers are going to turn out nice, but the algebra might get a little messy here, and you might need to grab your calculator for this. So the next part is we want to turn this into a 1. So what we'll do is we're going to multiply 1/3 times row 2, and that'll be my new row 2. And so, yes, you're going to get some fractions here. And so, I mean, you can use your calculator, but be careful because you don't want to put decimals in here. So let's see, we're going to get 0, 1, that'll be negative 1/3, negative 1/3, and then 0, 21, negative 1, negative 1. Okay, next we're going to turn this into 0. So what we're going to have to do here is multiply negative 21 times row 2, add that to row 3, and that will be my new row 3. And I think it actually will come out fairly nicely. I don't think it's going to be as bad as you might think. So let's see, the first 2 rows stay the same, so we'll go ahead and put those here. Let's see, negative 1/3 there, okay. And so now I'm going to multiply by negative 21 and add it to the bottom. So that's going to stay 0. Negative 21 times 1, then adds the 21. That will turn into a 0. Then negative 21 times negative 1/3, that actually becomes positive 7. And then 7 plus negative 1 is 6. So that turned out pretty nice. And then I've got the same exact thing right here. So that's going to turn into 6 right there. Okay. So now what we'll do is we'll turn this into a 1 right here and then do our back substitution. So what we're going to do is we're going to multiply 1/6 times row 3, and that'll be my new row 3. So let's see, I got 1, 5, negative 1, negative 4, let's see, 0, 1, negative 1/3, negative 1/3, then I'm going to have 0, 0, 1, 1 when I multiply it by 1/6. So once again, might make things a little bit clearer if I go ahead and put the variables back where they would be, okay? And so I'm going to go ahead and write that right here, okay? Give myself a little bit more room. So let's see, oops, keeps jumping. All right. So we're going to have x plus 5y minus z equals negative 4. Then we're going to have y minus 1/3 z equals negative 1/3. And then we're going to have z equals 1. So we already have one of our answers right there. Okay, and I promise you, I think this should all come out nice. I don't believe we're going to get any actual fractions as our actual solutions. And so you'll see that right here, that that's not going to happen. So we're going to have y minus 1/3 times 1 equals negative 1/3. So we end up with y minus 1/3 equals negative 1/3. And then when you add a third to both sides, you'll see that that actually turns into y being 0. So it worked out fairly nicely. So y equals 0 for that in our second row. We figured that out. So now what we'll do is take the top equation, plug in everything we know, and solve for x. So x plus 5 times 0 minus my z value, which is a 1. Got to put the minus there because it's part of the equation, right? And then equals negative 4. So let's see, that'll just go away. So we'll be left with x minus 1 equals negative 4. We'll add 1 to both sides. So we get x equals negative 3. So x equals negative 3. So then when we put this all together as our solution, we got to go in order of the alphabet. So x, y, z. So it's going to be negative 3, comma, 0, comma, 1. And so that's my actual solution for that. Okay. So I wish we could go more in depth on these, but we're by the standards of Texas, we're just kind of required to kind of give you an introduction to this. And so if you go ahead and take like linear algebra or something, you'll get much more in depth on this topic, and it's a very interesting topic. But anyways, I hope this is a good beginning for you.